Hi everyone, this is lesson number 3. I want to show how we can debug our program using built-in tools in the Arduino software. We will use the serial port and we will use a LED. We will write a program and I will show you what I mean. So first of all, we will go to our reference where we have communication commands. In the Arduino page, go to reference and we have a serial which is communication command. Let's see how it works. We have here an example. Okay, so the example we will take, these are the commands of the serial port. We use the println. The println is printing data to the screen. So let's take the example program, copy it to our window and change it a little bit. We will not need this variable and we do not need all of this. You can delete it and we will print hello world. We add also a delay, because if we will not do it, it will print all the time and our screen will be in a very short time full. Now I will compile this program, which is not compiling because I have deleted this variable and I don't need this command, so we will compile it again. Now we can upload this program to the board I have here and use the built-in tools serial monitor, which is open on 9600 baud rate. The baud rate means how many characters are the fastest speeds that we can send it to our screen. In this case 9600, we can divide it by 10 because each character is about 10 bits. Okay, so we have about 960 characters that we can send per second in this setup. What this program is doing is very simple. We're doing a setup which open our serial port in this speed, and in the loop we are using the serial println, which is print these characters, and ln is, after it prints it down by a line, because it is going to it is actually printing some characters that tells the serial monitor to skip to the next line, and then we are doing a delay of 1 second. Okay, so now we are going to add something to our program. First of all, we have a LED here. A LED is electronic parts that light out. The LED have a positive and a negative pins. If we connect it in the wrong direction, it will not light. That's all. Also, I have added a resistor. The resistor is because this LED is working on a specific voltage and a specific current. Most of the LEDs in this size are about 1.7 volts, and this Arduino is giving out 5 volts, so we have to calculate the resistor by 5 minus 1.7 and divide it by the current that this LED is working, which is about 20 milliamperes. This is how we can calculate the resistors that we need to use. If you are not sure about the positive and the negative, first of all, the negative is cut. The edge of the LED is cut. We can use a multimeter to measure it. Not every multimeter, because the cheap multimeter usually does not output enough voltage in order to see which pin is what. In this example, this is a fluke, this is a good one. We can see that if I put the red on this side and the black on the other, I have a reading. If I take the opposite way, it is open load, which means it is disconnected. So in this case that I can see something, I know that this side is the positive, which means it has to be the voltage that above 0, that is connected, let's say, to 5 volt, and the other side will be connected to the ground. Okay, now I want to add something to my program. I have special pins in Arduino. The special pins can do analog output. Okay, so let's talk about the analog output. It is pretty simple. We can see that if I'm putting out from the analog output a PWM, which means pulse width modulation. In this case, I can see that half of the time my pulse is, let's say, 5 volt, and half of the time it is 0 volt. So if this is a square wave, so the total value, let's say the average value, will be 50%. So in this case, the LED will light half of the power. If I will give a PWM of 100%, which is this one, it is always just 5 volt and not getting to 0 at any time, any point of the time. So this is 100%, and in this case the LED will light the maximum light it can give out. Okay, so what I want to add to my program, let's say we have a number that we will enter. Let's say we want to use 3 numbers, and in each one of them the LED will light in a different power. How do I do this? First of all, I have to remember that this kind of situations that I mentioned is not working for all the pins. If you will go to the reference and go to analog write, it is written in the site PWM, which is what I have explained. I can see that the analog, usually we have only a few pins that can do it. In the Uno, they say it is pins number 5, 6, 5 and 6. Most boards it is 3, 5, 6, 9, 10 and 11. On the Mega we have more pins that can do it, but since I'm using the Uno, we'll use pin number 5. There is some more information which I don't want to go into detail, but they are saying that the PWM frequency is 490 Hertz, and in some of the boards it can be 980 Hertz. Okay, this means is the speed of changing between high and low when we are outputting the PWM. To light a LED it is not important. If we want, let's say, to move a motor, it is a little important, because these numbers will give us a noise of the coil. So it is not very good to spin a motor with this message, let's say. Okay, so now let's learn how to do the reading. and see that it is working. So we will use a command which is switch this command take a parameter, and then we are comparing this parameter and decide what to do. For example, let's write my read, and then we open a bracket and close it, and doing a case for each value. Case 1, we will do something, and then we should do the break. Case 2, we will do something and then break, and case 3, do something and then break. Of course, we can add more cases, and this command also have a default. It is not important, and we can run it this way. So here we will define what is the power that we want out. So let's say this will be 20. The number can be between 0 to 255, which means 255 is the 100% power out of the LED, and 0 is the minimum. So here we put my LED and number, and case 3 we put my LED and maximum value. Maximum value, this will be highest light. Okay, now we have to read this value. How we will read this value? Again, I don't remember, so I will go to serial port. Let's go to serial port. Okay, so if I don't find it, here it is. Okay, if serial available. Okay, I have a good example. If serial available, blah blah blah, so we will do here read. So let's copy to our code. This is the best way to look at example and implement it to our code. So let's do it. So if blah blah blah, and what do we want? If we want to do let's say all this. So incoming byte will be my read now, because this is the value that you want to read and do with it something. Now of course, if we have it, we will need to add a variable for it. Okay, so let's write a variable for my read. Define a variable. Okay, let's use an int. I think it will be okay. If not, we will change it. This is just to define this variable that I'm going to work on it. I still didn't do anything. Let's see if it compiled. Okay, my LED was not declared also, so we will declare it also. Compile it again. Okay, this is compiling, but we still haven't done anything with this. So the last part that we need to do is to do the analog write command, okay, which is in the reference. Let's search for the analog write. analog write PWM, analog write example, blah blah blah, analog write p number and value. Okay, we have not done two things yet. First, we should define that we are using pin number 5. So how do we do it? This is quite simple. We have a pin mode command. So we'll use pin mode 5, which will be output in our case. And then we need, after we know what to write for it, actually instead of doing it, we can write the analog write here, but I will put it here. So analog write our pin number and the values that we want to write. Let's see if I'm okay. We don't need now the hello world, so we will move it away and download this code to our board. Now, of course, what we have to do is to connect it to the right place. So we need to connect it to pin number 5 and to ground. So let's do this one. I think this is pin number 5 and this looks like a good ground to me. So now we need to check what we've done. So again, I'm opening the monitor and let's press 1 and we can see that the LED is lighting. How much it is lighting? Let's look at the code. 20 out of 255. If we will press 2, oh, this is much better, and 3 is the maximum. Okay, so we have 1, 2 and 3. So in this way we can debug by using a LED, and we can debug by printing out a command. Thank you. Bye bye.